The next stage I'm going to add to this in the helper classes is going to be some platforms. Now, platform is just going to be a generic class to represent any kind of object that's an obstacle. So I'm going to actually make just a generic one here called platform. And I don't intend to put any code into this. It's just an actor. That's all I need from it, is to know that it's an actor that I can put into Greenfoot. And inside this platform, anything that I want my actors to react to will be subclasses. That way, when I want to call for platforms, I don't need to know the specific kind. I just need to know that it's a platform. So let me show you here. In this video, you can see I just have this one picture here. Well, I'm going to do a quick edit, and I'm going to pull out the bottom of here, this sand. So here's the cropped sand. It's just the bottom of that picture. And if you have a picture that you want your actors to be able to react to, that's what you would do too, is crop out any part that you want to become a platform or an obstacle or something that they have to react to, is you'll have to crop it and turn it into one of these actors. So I have my sand image, and I'm going to put that into my game as well. So I'll just call this sand, and all I'm going to do is associate the image to it. And now if I was to take the sand platform or actor, you can see it'd be able to cover up the screen where I want it to. So that's basically what you would do too with your platforms, is then when you put it over top again, and you say that's where I want it, and you make your adjustments, you can stick it into Greenfoot and then ask it what the coordinates are. So 450 and 484. So then I would know where to put this platform so that my actors react to it. However, I actually have a better way of putting this platform into the game, and that's because I know it's right at the bottom there. I can put it in dynamically when I run the program. So here, I'll put my platform in. Sand, I'll call it bottom is new sand. And all I'm going to say is that I want to put it down at the very bottom edge. So I'll call that int sand x, and that'll be half of its width. Whoops, that should have been a dot. And then sand y is going to be that image. I want to get its height divided by 2. And the thing is, I have to subtract this from the world, which is the ocean I'm in right now. So I'm going to say just get the height of the ocean and back off by half of its height, and that should put it straight onto the bottom. So then I can just say add the object, the bottom, sand x, sand y, and then when we run Greenfoot here, hopefully you can't tell that it's even there because it's just been placed over it, but you can see when the mouse goes, there's actually somebody there. So the mouse is signaling that there's something to it. So every time my world starts, now I actually have the bottom of the sand here. So this is how you would add your platforms. Just create another subclass that you can keep extending different types to. Notice I haven't even put any code in it because I don't intend for there to be any actions. All it is just an object sitting there that will block other actors. Now it's possible too that you want to have characters that still act this way and move and are maybe more dynamic. Like for example, like if you had a car or a skateboard or something that was moving and you wanted that actor to be able to jump and land on top of that other actor, then you'd have to be a little bit more creative about where you place it in the hierarchy for the platforms. So you could stick the platform underneath the bounded actor or somewhere else in here to make use of some of those methods for movement, or even the gravity mover, anything like that. But for now anyways, we're just talking about plain vanilla platforms that they jump to or walk on, etc. So I'm going to add now a platform mover class, and it's actually bounded by gravity still. It's just that it's not the bottom of the screen or the sides or the top that block it. It's any platform that it hits. So there's again no picture because it's just a generic class. So it's a platform mover, and all I'm going to do is program in the code that tells this actor that they've bumped into platforms and that they need to readjust. So it's going to follow the same protocol that we talked about with the gravity mover, which is to process the actions, process the obstacles, move, and then apply the physics. So I'll just show you the parts of it that we're going to end up adding to it, and I'll start by getting my editor going here. So because I'm going to obey that protocol, I'm just going to call on the gravity mover to do all the lifting here. So I'll say super.act, which means it'll follow that same sequence as before. So in fact, I could delete all this code just to enforce Java to go up to the superclass and use its code. But I'm doing this on purpose just so you can see that I am in fact calling up on the gravity mover class to do some acting. And gravity mover has the process actions, process obstacles, move, and apply physics sequence in it. So here, there's a few items that I'm going to keep track of for this platform mover, and I'm sort of envisioning like the Mario character, from classic Nintendo as sort of my model. So what I'm going to give it is just an int to represent its speed. And that's basically for moving left and right, that's all. I could just set it in the horizontal velocity, but anyway, you'll see where this comes into play here with the speed. I'm also, because that platform mover only faces left and right, I'm going to have a flag here that's facing to the right. And that'll tell me which way the character is facing, so I know whether I have to flip the image or not. So we'll go and initialize this stuff, platform mover. Oops. And I'll get the superclass to build it. The default speed, let's see here. I suppose I'll just start it at 1, but of course we could make that something faster once we play around with it. And facing to the right is going to be true when I initialize it because it's facing east when all things start in Greenfoot, or at least if you've aligned everything properly to Greenfoot, it should be facing towards the right. So I definitely want to give some access to the speed because I'd like to be able to set and get the speed from people who subclasses that might want access, or just people using the class. So those are my accessors to speed. Then and mutator. I don't want to give access to facing to the right, which again is another good reason to keep it private, because if somebody messed up the consistency here, my image might be walking backwards by mistake. So I'm going to manage all of the facing right on my own, and I'm not going to let anyone else see it, so I've made it private. And remember, private is only visible to people working within this class, or to you and me, that means typing the code in this file right here. Any other file has no access. So that means if I extend this again, subclasses won't be able to get hold of facing right, not unless I give them a method to do so. So the first method in that sequence that we were working with was to process the actions. So that's what I'm going to put up here. And when I process the actions, what I'm going to do is start by, this is one I had to implement because it's a abstract base class. So I could pass it off again and force you to do it when you make your subclasses, right? I could just do this, call this an abstract class, and then move on. But I might as well do this one with some default behavior here because, again, my sort of inspiration for thinking about what this character would look like is, that classic Nintendo sort of platform mover. So I'm going to implement process actions, and basically I'm just going to use left, right, and up keys. That's all I'm going to make happen. So we'll check here if Greenfoot.is key down, checking if the up key is down. Actually, I'm going to make this left to start. I'll explain why in a minute here, but if I'm moving to the left, then basically what I want to do is make my character go in that direction towards the left. So I would set the horizontal velocity to be the negative of whatever the speed of my character is. Now, we also could have turned the character. So if he ended up flipping, then I need to take that into account here. So what I'm going to check here is if I was facing to the right and I push the left key, that means I also have to turn the character, I guess we'll call it an actor here since that's what we're dealing with. We have to turn the actor as well as move it. So in here I'll put in the code to turn it. And to do that, I'll just get the image and I will mirror it horizontally. And I'm also now facing left, so that's where I'm saying I could keep the consistency of whether I'm facing right or not all within the class and not let anyone else have access. So that handles the left key and turning the actor if need be when they move left or right. So then the other one here is going to be else if Greenfoot.is key down. If that is to the right this time, it's going to be very similar. So I'm going to copy and paste this code here just to save us a bit of time. I know I'm always talking about how bad this is, but I figure you'd rather watch me type as little as possible here. So this time, what I'm going to do is, if I'm not already facing to the right, then that means I need to mirror the image. So I mirror it and I say now I am facing right, and this time I'm setting it to the positive velocity, so it'll be moving in that direction as well. Okay, and then the last thing that we would need to check is, like I said, if the up key goes, that I would jump. But I'm not sure if you remember the way this gravity mover works is you set the velocities in motion and then gravity will take over. And in this case, if I set the horizontal velocity, gravity won't have any effect on it. There's no friction in our character, so basically it would just keep moving even if you weren't touching the keys. So to combat that behavior, what I'm going to do here is make sure that if you're not, hard to type and talk at the same time, if you're not touching the left or right key, then you should make sure the horizontal velocity is 0 because you're not applying any new velocity to your character. So that will take care of whether or not it moves left or right. And now the last thing was the jump we wanted to do. But if you think about in physics and the real world, when can you jump? Well, you have to be touching something to exert the force, right? You have to be on the ground or on a platform. So that's what we're going to do now is, before I can finish this, I need a method to tell me if I'm on the ground. So there's already one in the parent class, but it only checks the bottom of the screen, and that's not quite good enough for me. I want to make sure that I'm also able to check and see if I'm on a platform to do it. So here I'm going to start with public boolean on ground, and this will override the parents method. So to this platform mover, I'm still going to allow it to bounce off the sides and the top and the bottom, or at least react to them, but I also want to check for platforms. So first of all, it means I'm going to need to scan through platforms, and I'm going to need to import a couple of Java classes to help me there. So the list class and the list iterator. Now, it's possible to use arrays, because you could just get the list and then convert it to an array in order to scan this. And it's also possible to just scan through the list without an iterator. But I'm going to show you the way this protocol goes too, because for those of you in AP, knowing how to use the list interface is also part of your requirements. So the first thing I'm going to do here is get a list of type platform, and this is going to be to call on get objects from the world. So I actually need to go get world.getObjects, and the type is platform.class. Now the list is the collection of objects that I have, but it doesn't actually give me, well, it does give me some access to platforms. I suggest you Google the list Java doc, and it will show you there's a get method if you know the index, other things like that. But again, I told you I was going to do this to show you how to traverse a list using an iterator. So the way I ask for it is I go to the platforms, which is the list, and I just type in list iterator method, and this will give me a way to traverse through that list. I'll get the usual coordinates and things I'm going to need to know about the location and the size. So the bottom here would be at the y coordinate minus the height over 2. Sorry, that should be plus the height over 2. and then the width. Okay, so just a bit of stuff to help get me going here so I know where the actor is in relation to the world. And what I do is I'm going to use a while loop here and say while the iterator has a next object. So this basically, the iterator keeps track of the position that it's in the list. So right now it's at the very front. So if there's something there, has next will return true. And then I can ask for the next thing by just saying it's a platform that the iterator is pointing to. So that will be iterator's next object. So basically, I know that at this point I've got access to the first one, and then this loop will run all the way until the iterator says I have no more to give you. So when you call next, it automatically advances the iterator to the next position, so it's waiting for you to call it again. Now I'm going to need to get some of those things from the platform too, so just bear with me for a second here. Okay, so now the top of the platform is going to be at that platform's y minus the platform height divided by 2, and the platform's bottom is py plus the platform's height divided by 2. So now what I'll do is I'll check and say, maybe I'll leave a little extra space here, is I'll say if the platform top is less than or equal to the bottom of the actor, and the bottom of the actor is less than or equal to the platform's bottom. And it's kind of turned upside down if you were to think about it, right? Normally you'd want the bottom to be the smallest and the top to be the biggest, but because of the way the coordinate system works, that's why I've got it flipped here. So if that's happened, I know that the bottom of that actor is somewhere between the top and bottom of this platform, so there's a collision there, or a possible collision at least, for me to see that it is actually on that object. So it's tempting to then to just say, okay, let's return true here and say that yes, I am on the ground. But it's also possible that I'm, say, somewhere beside that platform and I'm falling past it, so I'm not actually standing on it or near it. I'm actually I'm in the process of falling through it. So I'm going to create another helper method here, and this helper method is going to tell me if two line segments overlap. And I'm not using any private members for this, it's just a helper function. So I'm going to create it as a static one which all the platform movers can use. They don't need to create their own version. So as a general rule, if you don't access any private member variables, or you never access the word this, is another way to think of it. So even though it's not written there, I'm actually making an implicit call to this object. If it's not associated to any one object, you should use the static qualifier there to reduce the overhead of your program. And in this case, it's just math. I'm not actually doing anything with the specifics. So this will be segment 1's minimum, then segment 1's maximum, and segment 2's minimum, segment 2's maximum. So there's a bit of math here, and I would invite you to double check it, but this is usually known as the triangle inequality that you're checking. And it's basically going to check if the sum of the two pieces is smaller than the biggest to the smallest, meaning that, the sum of the two pieces is biggest than the smallest to the largest, meaning that there must have been a gap between them. So the first distance would be segment 1's maximum minus segment 1's minimum, and then I would add that distance for segment 2's maximum minus segment 2's minimum. So that gives me the sum of the two distances. Now I need to know what the minimum is, so I'm going to use the math class. You could do a quick if-else statement here, but the minimum is a competition between segment 1's minimum and segment 2's minimum, and the maximum is a competition between segment 1's maximum and segment 2's maximum. Now I'll make up what would that maximum distance be if I was to go from the maximum to the minimum. And this is where I'll make the comparison to see if they overlap. So if that's the case that they do overlap, then the sum distance of the two separate pieces must be greater than this maximum distance. So I'd invite you to try it with a couple of line segments of your own and see if that makes sense. But anyways, there's no getting away from math and computer science. So that's what I wanted to check now, is that this actor actually overlaps the platform that I'm standing on. So I'll check like this. So the actor would start at x minus its width over 2, and it would end at x plus its width over 2. Then this platform, the left side would be the platform's x minus the platform width divided by 2, and the platform's x plus the width divided by 2. So I'm going to check to see that those segments overlap. And now I know that I've at least got them, those two things are right over top of each other, and they're actually touching, the bottom of the actor touches that platform. Now, you would have a problem here if you tried to compile, because you're not actually going to be returning something. You return true only in this situation. So it's possible that nothing is on, that the actor is not on the ground, and it gets through this loop. So at this point, you would know that it's got to be false. You're not on a platform. So the other thing I'll bring up at this time is that you should know the in this case, it won't react to the bottom anymore if I ask if you're on the ground. The bottom of the screen won't say yes, I'm on the ground. Only platforms will, because that's all I'm scanning through are the platforms in the world. And I've done that on purpose because I'm thinking sometimes I want a platform where I don't fall through the ground like that, and I still want to be able to measure that. So I could do it really easily now with my classes. I could be moving along a platform and check to see if I'm out of bounds, because if I fell out of bounds, then I'm at the bottom of the screen and I'm actually out of bounds there. So I'm not going to add it into the on-ground method here, but you can always change your subclass to include that behavior as well. But I'm not taking that part from the parent class. Now, there's other times when I'm actually going to want to get access to the ground as well. So while I'm here, I'm just going to quickly make a method called getGround, so that way I can find out who is the actor standing on. And basically I'm talking about the exact same thing here, but I'm not going to return true. I'm going to return that platform, and I would return null to say there is no object when I get through that loop and I haven't found anyone. So again, copy and paste. By now hopefully you're getting the hang of me saying that's such a bad design principle. You should now take this and think about how could you rewrite it so that you would know if you're on the ground using the method you just wrote. And it's pretty simple. All you have to do is return that getGround is not null. If it found ground, then it's not null, so it would return true. So that method then can reuse this code, and I don't have to worry about the problems that come along with copy and pasting and all that extra code and things that I'm not reusing. So down here, if you remember, the whole reason we got on that tangent was so that I could make it jump. So I'm going to say if Greenfoot.isKeyDown, and if the up key is being pushed, and you have to be on the ground in order to do this, then you're going to jump. So the jump that I'm going to make, I'm going to use the jump for method. That one's more accurate because I know exactly how many moves I'm going to jump up to the top, whereas the jump to a certain height only works for its best estimate, which could mean I go too high. But here I'm going to say jump for 12 moves. So basically I'm going to go 12 moves up to the top and then V12 moves back down to the bottom from gravity. Of course, I could hit something along the way that stops that, but that'll be about the default jump, the height of the jump, and you can change it here if you'd want to change your default, or again, when you make your subclass, you can change the behavior of jumping too. So that's the basic actions then for my mover, and you can specialize your own class and keys and things to process actions. So it's important when you remember the protocol is that processing actions is trying to set the horizontal and vertical velocities, and it might also require that you set the rebound so you know if the object's going to bounce or not. Okay, so then the next thing that we would do is we would need to know about processing the obstacles. So that's what I'm going to put into here now is a public void has to return a location. So public location process obstacles, and this is just going to adjust the action that I've tried to make so that I don't go through an object in the world. Now, again, I've obviously thought ahead a lot before doing the video, or I hope it's obvious that I'm not just winging it, because the code gets quite complicated and hard to follow if you haven't actually done something beforehand. So I know that I'm going to use a helper method here, and what I'm going to do is I'm going to make it public because maybe the subclasses want to know about this. So it's going to be a collision type, and I'm going to call it get collision type. And what I'm going to want for this is a platform, and I want to know how much you're trying to move. And what it'll return is the kind of collision that would happen if this object, this platform mover, is attempting to move that in this much for X and this much for Y in relation to this platform. So it'll tell me if I hit left, right, top, bottom, or none of it. So I'll get the usual culprits here for dealing with locations. And I'll get the width. And I'll get the height. Now, I want to take, again, there's some math happening behind the scenes here that I've had to sketch out before I did this, but basically I need to know where the right edge of the actor is, the left, the bottom. I need to know all these coordinates. So the right x coordinate is going to be x plus the width over 2. And then the next position where it's trying to go to is going to be the right x plus dx, the amount of change I'm making. So same thing with the left x. Next, left x is going to be left x plus dx. Okay, so really quickly here, bottom is going to be that y coordinate plus the height over 2. The next bottom is going to be the bottom plus dy. The top is going to be y minus the height over 2. And the next top is going to be the top plus dy. Now, I still have to do this similar process here for the platform in order to know all about where it is and its locations. So I'm going to go and get that image. I'm going to have to call it something different this time, so I'll call it platform image equals p.getImage. And then I'm going to start pulling out the pieces. So that'll be platform.getX. Py is platform.getY. The platform's width is the platform image.getWidth. And the platform height is the platform image.getHeight. I need the platform's top, so platform y minus the platform height divided by 2. and platform bottom will be the platform y plus the platform height divided by 2. I'm going to need the platforms, we'll call this left x, and that's going to be the platforms x take away the platform width divided by 2. And then I need the platform's right x, which is px plus the width divided by 2. Okay, so these are just our background things here in order to start making a calculation. We're almost there. So what I'm going to do first is make sure that what I'm trying to do here is moving. There's no collision happening if the actor is standing still. So I guess I'll check for dy first, and then I'll deal with vertical collisions, and then I'll check for horizontal collisions. And if nothing happens in those collisions, then at this point I know I can return the collision type none, just to signal that nothing collided with this platform. Now this also helps me avoid dividing by 0 because I am going to be calculating slopes. This will probably be I'll do the dx math first. It's probably the most familiar for you. So remember, you got two integers here, so dy dx. You have to cast it or you're going to end up losing some of your data there, right? And then I need to calculate a whole bunch of places where these things would intersect. So what you have to envision if you're thinking of the math involved in the collision is the points forming a line where it's currently at, and then moving to where dx dy would take that point. And we'll see if that line segment that would make it from the current position to the next one, if that line segment intersects any of the line segments on the platform. So ultimately we're going to be dealing with integers. So I'm going to call this the bottom right y intersect. And I'm going to have to convert it back to an integer, so I'm going to round my answer to get as close as I can here. So I have the slope, and this is platform's left x minus the left x of the actor. Sorry, that would be actually right x. Plus the bottom. So what I had to do was use a point slope form of a line to find the intersection, and this is the math that would get me that position. So I don't want to go too much. I understand that you're probably a little bit lost on the math here. I'm obviously skimming it quite quickly, but that's not the focus of what we're doing here. I'm happy to discuss it in class with you if you want to talk about how the math works. It's actually not that bad. It's just finding some intersecting lines, but I don't want to. I've already spent too much time talking about it, so let's move on. So I'll just so these will be my left ones, bottom left, top left, and then there's going to be a quick change here. This one should be top. So I can see if it hit the left side of the platform. And to hit the left side of the platform, that means the right x of the actor has to be currently less than the left x of the platform. And then when I move it, the next right x would have to be greater than or equal to the left x of the platform, meaning it's gone through that. It's attempting to go through the platform. And it's not enough that it goes through, because it might not be that vertically I'm actually aligned. So I'd have to check that the segments overlap to make sure that they are in fact in line. So this would be the segment made from the top right to the bottom right, and from the platform's top to the platform's bottom. So if they're overlapping segments, that means I know I've made that collision. So I can return collision type dot left. Now, the other thing that could have happened is I could have hit the right side, which means the left x of this actor would have to be greater than the platform's right x, and the next left x is going to have to be less than or equal to the platform's right. So that would be it moving, trying to move through, but it doesn't count unless it actually collides. So let's see if these segments overlap. This time I'm working from the top left y and the bottom left y, but the same segment here on the platform. So this would be to return the collision type for right. So it's some similar math that I'm going to do. So what I'll do is I'll pause it here and I'll do the typing because, again, it's not something I expect you to pick up from just watching me code it, but I'm happy to discuss it with you if you want to talk about the strategy here. So here's what the finished result would look like for checking the y coordinate. The math is pretty similar, but at least it looks similar. But this time I'm checking to see if it went through and hit the top of the platform or the bottom of the platform. So that's my helper method, which will tell me what kind of collision I've had with that platform if I attempt to make this move. I'm going to end up using that when I process the obstacles. So the first thing I'm going to do is use that code that was already there, which was the parents class process obstacles. So I've done all that code already about finding out if I'm bouncing along the edge of the walls. So I'll take advantage of that and I'll find out what location the parent class would send me to, so I can incorporate it and not have to retype it or recode that. And I'm going to need to go and get all the platforms in order to process them. So I'll get those platforms. And I'll get a list iterator for them. And I want to get the usual coordinates and things. And now I need to know, whoops. Now I need to know about how far I'm attempting to move it. And what I'm going to do to incorporate what I've done previously is if there's been an adjustment to how far I'm supposed to move, it'll be reflected in that new location up there. So, I could do something like this, get the horizontal velocity. That's what I would like to move, but it might be that I'm hitting the side of the screen. So the way I'm going to incorporate it is, rather than use the whole thing that might bump the screen, is I'm going to use the x coordinate I have right now, and I'm going to compare that with the location I was given to see how far apart I'm allowed to move. So I could go location.getX minus that x, and the amount of change that I could still do for the y would look like this. Now, if I didn't bump into anything, then I'm allowed to move the whole, if I didn't bump into the walls of the screen, then this would return the full distance that I do want to move, which is the horizontal velocity or the vertical. So anyway, these are still preserved, but the nice thing about it is I've adjusted my distance already based on the parent class. Now, while the iterator has a next platform to go and process, that's what we're going to do here, is attempt to find out if we need to move or not. So in this case, I have a platform, call it P, is the iterator's next. And I'm going to get the usual suspects here. I'm just going to copy and paste it so that we can use it, which are its locations and things like that, the X, the Y. Maybe I'll move this down just so it's together with width and height. And now I also need to manage collisions that happen. So it's possible that a collision has already been set here, In fact, it will be. It either collided with none of the walls or, top, left, bottom, or right. So something's already been initialized here, which is good because that's set the last collision already. But I definitely need to keep track of collisions. So I'm going to have a variable here, collision type. This is the collision that I'm currently looking at. I'm going to use my helper method here. So get the collision type from the platform, dx and dy. And then I'm going to now process this obstacle. So the first thing I'm going to do is I'm going to ignore it unless I actually collided with something. So if the collision does not equal none, then we've got work to do. Otherwise, we can basically just keep on going. And the net result at the end of this loop will be that we just have to return a new location from the x plus dx and y plus dy. So we'll go through and look if we have to make any adjustments to dx and dy for the amount of change that's going to happen here. And I'll start by checking the different collision types. So we have to do one for each of them. So if collision is the collision type for the top, and I'll just, I got 4 of them to do here. I need to do the bottom. I need to do the left, and I need to do the right. Okay. So now I can put my code in here. But one thing I have to note is in the design I need to keep an update of what collisions have happened. So in here I'm going to say set the last collision to be this one that I've just found. Because I know it's not none, I have to record it here. Okay, so these are going to be very similar, but you'll just have to bear with me while I work them out. So if we hit the top, it's dy that we have to make an adjustment to, and basically I just want it to stop right at the top of that platform. So I'm going to take the largest value, so I have to do a little bit of rounding in here to make sure that I stop at least at the top of it and not, that I'm at least on it and not even 1 pixel above it, but that I stop right at that edge or just slightly under it. So the math.ceiling, and the math that I'm going to be looking for here, we'll start here with the platform. So the platform's y, take away the platform's height divided by 2.0, is going to give me its top. Then from that, I'm going to subtract the player's y minus its height divided by 2 as well. And that'll basically put it right to as far as it's able to go before it actually would go through the obstacle. And again, because I've made a change to dy, I have to scale dx in the same way. So I'll say math.round, and if you remember from before, we had to cast to a double. And this is get the vertical velocity. Okay, so it's going to be similar. I'm going to borrow this code here just to speed things up. There's a couple quick changes I'm going to have to make. But anyways, I'll pause the video here and you can see the finished product. So there's the rest of the adjustments, but the idea is the same. For example, if I'm going to collide with the bottom of that platform, then this is where the bottom of the platform is, this is where the top of the actor is, so I'm just going to take the distance between them and make that the y distance, and then I need to scale my x distance, and similarly with moving it to the left edge of the platform or the right edge of the platform. So by the end of this now, I've processed all the obstacles so that I will be just bumped right up against the edge, and then when I apply the physics, that'll happen on the next round when act is called. So if you hung in there, that's all we need for the platform mover now, that helper method to work in conjunction with this. But this will actually give me the code to make something move along a platform. And hopefully here everything's okay. Oh, forgot a bracket somewhere. Now hopefully everything's okay. Famous last words. So these are capital M's by mistake. But anyway, I'll leave this class available for you to use, and I'll show you a demonstration with our next actor, which is going to be the crab. So this needs to come from the world. And there we go. So that's the platform mover, another generic class that you're able to use now with your own. And we're going to build, the next object is going to be a crab that's going to start attacking the shark.